Everyone, welcome to another episode of 30-day challenge. Uh, let's get on with the question. So, today's question is we need to find the leftmost column with at least a 1. The question seems a little big. Let's go over it. So, a binary matrix means that all elements are 0 or 1. For each individual row of the matrix, this row is sorted in non-decreasing order. That means that in a way it's like an ascending order where all the smaller values appear first and then the larger values. Given a sorted binary matrix called binary matrix, sorry, return the leftmost column um, with at least 1 in it. If such index doesn't exist, return -1. You can't access the binary matrix directly. You can only access it through this interface. So basically, okay, so they have provided the API. We just need to call this and get the values. Submissions making more than 1,000 calls will be judged wrong answers, very solutions. Attempt to circumvent the judge will result in disqualification for testing purpose. Okay, let's look at the example. So as it says, the row is sorted in non-decreasing order. That means that this is row 1, this is row 2. So it's, or you can see it's, sorry for this first example, it's already sorted in 0 0. So it's sorted in non-decreasing order, then 1 1. So we will return this column 0 because in the first column we get the value -1, right? So it says the return the leftmost column with at least a 1 in it. So this is the column which appears first with 1 in it. Similarly, we have example 2, which is 0 1. Okay, and in this case there is -1, and in this case we'll be returning column 1, right? It says submissions making more than 1,000 calls. That means, let's see the constraints. So m and n is 100. So that means obviously we can't do brute force, which is going over all the indexes, which is m cross n, which will be 10 to the power 4, and we need to be less than 1,000 or equal to it. So that means, and we are given that each row is sorted in non-decreasing way. So when there is a sorted keyword, we know we might have to use binary search somehow, and I think binary search will make it m. And if we do binary search on columns, or maybe we, okay, so let's discuss this with the example here. I'll take the last uh, matrix as my input is 0 0 0 1 0 1 1 and then 0 1 1 1. Okay, so we need to return the answer is this column, which is column numbers are given like this 0 1 2 3, right? And then we have rows 0 1 2. So rows are sorted, right? So this whole row is sorted in non-decreasing order. Row 1 is sorted in non-decreasing order, row 2. So now if we see the constraint m and n is 100, so m is, let's say, row number, and column is this. Now we need to return the leftmost column. So that means we need to go from left to right, right? Column wise, from column 0 to column n minus 1, and in each column we'll be looking out if we have a 1 or not. But we can't traverse it brute forcefully, like doing a for loop on row and then a for loop on column and going over each cell to check 1, right? Because that will give us complexity of m cross n, and that's out of bounds from what the question says about the 1,000 calls. So how do we achieve it in the time frame? Let's say I iterate over all this n columns, right? Like column 0 to column n minus 1. So that is O of n. And then for each column, because my rows are in sorted form, so I'm sure that the smaller values appear in the initial columns and then the larger values appear on the rightmost side. I can run a binary search on each row, and that will give me log of m, which will be max could go to 1000 calls, right? And that's acceptable. um, so let's try to look it into the code. um, First I would like to get the dimensions of the matrix, which is dimensions binary matrix. How do we call it? Dimensions. Okay. And then I have INTM, which is the number of rows, dimensions of 0, and then INTN is this is number of rows, and then this is number of columns. So then what we do, we start a for loop on each column as we discussed. Let's name it as j because it's pretty confusing if we use I, because generally when we do a brute force over matrix we use I for row and j for column, right? So because we are now iterating from column leftmost column to the rightmost, we use this, and then we do a binary search, right? So my start index will be 0, my end would be m minus 1, right? While start is less than end, and mid will be start plus end divided by 2, right? And then here we check if we get the value of the cell. The cell value is equal to how do we get that? It's using this. So we use the object, and we in our get the x value will be mid, and this will be j for the column j. If cell value equals 1, then we return j, right? Don't care. Else if cell value is less than 1, which is it's 0, right? So in that case we need to move towards the lower half of the column, right? So we do start is equal to mid plus 1. Yeah, that's it, I guess, because it's in a but it can't be in a sorted form because the rows are in the sorted form. So there might be a case where I have a row like this, and then a row like this, and then a row like this. So we might miss it because what can happen is my mid, if I start from here, I'll check, I see that it's a 0, so I think I need to start from row, and because my rows are sorted, I split the rows into the half and then check the columns. Yeah, I get my bad. And then I keep a int min index, which is for now could be min index is, let's say, more than 100, right? And then I update my min index if I find it. So I need to iterate over rows actually, my bad. Yeah, and then for each row I do a binary search, and if I find a 1 in that row, I check with the min index and I update the min index, so that way I get the min column count. So here what I can do is my end would be n minus 1 because I'm running on the column. So this would change, would be I comma mid, right? If cell value is 1, if cell value is less than 1, else if it's not equal to 1, that means I'm on the first half of the column, which is like I am in this part, right? Let's say my my value is mid value come gives me 0, so I know that 0, that means 1 will obviously will be on the right side, so I move my start. And if I find 1, I update the min index to be min of min index comment comma min. Yes, correct, comma min. And then that way, once the for loop is end, if my main index is less is not equals to 101 or not equals to 101, return min index, because that means I have found the min index. Otherwise, if I didn't find it, I'll return -1. Right, and it should be less than. Okay, time limit exceeded. Why? Oops. Okay, because I need to break it here. Okay, let's run over this and then save this and create a new one to see what I'm doing wrong here. 0 0 and 0. Okay, 0 0 and 0. What's this? 0 0 and 0 1. Oh, my start should be equal to end. Yeah, that's the wrong case I was doing. So this should give me 1. Correct. My start was not equal to end. Okay, wrong answer. So let's see how many test cases are we passing. Awesome. So that means we are nowhere near expected 0, passing 2. Let me take a new page. Let me copy it here if I can. Okay, so this is 1 2 3 4 5 rows, and then 1 1 2 3. Oh, if it's equal to 1, maybe I can find it in the column smaller than this, right? So I will go mid and mid -1, correct, in order to find the, yes, my bad, this was a mistake. Because see, in our first case, like if all the columns are 1, so my mid will land me 1 here. So what I was doing, I was checking this value of the column and breaking it out. What if this is the one, I know for sure that there could be a possibility of 1 being here, so why not explore that? So let's see, this should give me 0 here. Okay, awesome, let's submit it now. Awesome, so it's accepted now. I hope this question was clear and easy to understand. It was a very interesting problem. If you like the video, please subscribe to my channel and give me a thumbs up. Thanks everyone.